Okay, so I want you to picture a scenario. It's Monday morning, you're caffeinated, focused, and you're looking for a document.
Yay.
Maybe it's a template for, I don't know, a rental agreement, some kind of legal form. You search for it, you find it, you download it.
So far, just a typical Monday.
Exactly.
Yeah.
But let's say you're a bit of a power user. You're security conscious. You don't just double-click things blindly. So you try to open this file with a serious tool. Maybe you use 7-zip or WinRAR, the gold standards.
The tools that are supposed to show you exactly what's inside the box before you actually open it.
But the tool just spits out an error. It says, unexpected end of data, or maybe headers error. Basically, it tells you this file is garbage.
It's broken.
Corrupt.
Yeah. And for 99% of us, and this is the important part, for 99% of automated security scanners, that is the end of the road.
You just assume the download failed, you delete it, and you move on.
But today, we're diving into a case where that error message isn't a failure at all. It's actually a disguise.
We're talking about GootLoader. This is a piece of malware that relies on being broken in order to work. It survives because it fails those standard checks.
It's a really fascinating paradox, isn't it? In software, we usually obsess over correctness. Code has to be perfect to run.
Right, the structure has to be exact.
But GootLoader just flips that completely on its head. In this case, chaos is the key to the castle.
And just to set the stage, GootLoader isn't brand new. It's been around since 2020. But the research we're looking at today, from the team at Expel, specifically Aaron Walton, it covers a resurgence we've seen in late 2025, early 2026.
And they've introduced this new trick that creates what you're calling, impossible archives.
Impossible archives, and that's the right word for it. They are constructing ZIP files that, they technically shouldn't even exist. They violate the fundamental laws of the file format.
Right.
So our mission today is to unpack, and yeah, pun absolutely intended, how GootLoader builds these Frankenstein archives. We're going to look at how gluing 1,000 zip files together, blind security tools, how they use hash busting to stay invisible, and finally, a surprisingly low-tech trick involving Notepad that can stop them dead.
It sounds like a classic David versus Goliath story.
It is.
Yeah.
If David was a malicious script and Goliath was, well, the entire Windows operating system. A very messy, very chaotic David.
So where do we start?
Let's start with the file itself. What exactly makes these archives impossible? Because to me, a ZIP file is just a ZIP file.
Okay, so to get the trick, we have to get a little bit technical about what a ZIP file actually is. We think of it as just a bag you throw files into.
Yeah, to make them smaller.
But digitally, it's a very structured container. It has a header at the beginning that says, hello, I am a ZIP.
Yeah.
Then you have the compressed data and then a footer at the end.
Okay, so it's like a book. You've got the cover, the content, and then the index at the back.
Precisely. And a typical ZIP file is one single book. But what Aaron Walton found is that this new GootLoader variant isn't one archive. It's a concatenation of anywhere from 500 to 1,000 separate tiny archives.
Wait, hold on. Pause right there. 500 to 1,000 separate ZIP structures all smashed into one file.
Yes, just appended one after another. A long, long chain.
That sounds incredibly inefficient and just messy.
It is. It's huge and it's messy. Imagine taking 1,000 different pamphlets and just gluing them together into one massive, chaotic brick.
Okay, so why? Why do that? Is it just to make the file heavy? I know some malware uses file size to bypass scanners that have limits.
That's part of it, for sure, but the real goal here is to confuse the inspector. When a strict analysis tool like 7-zip or WinRAR looks at a file, it expects order.
It's looking for one book, one header, one footer.
Exactly. And when it sees this monstrosity of 1,000 concatenated archives, its parsing engine basically panics. It hits conflicting markers, headers where there shouldn't be headers, footers in the middle of the file, and it just says, this is invalid, I can't parse this.
It throws an error.
Throws an error. And in the world of automated security, like a firewall or an email scanner, what happens when a file throws an error?
Well, it usually gets marked as corrupt or unscannable.
Right. And because you can't just block every broken file, files get corrupted legitimately all the time, the scanner often just shrugs and lets it pass. Or, and this is crucial, it fails to extract the malicious payload inside.
So the broken nature of the file is effectively a cloak of invisibility against the smart tools.
It's hiding in plain sight by looking like garbage.
Okay, but here's the obvious question you should be asking. If WinRAR can't open it and the security scanner can't open it, how on earth does the victim open it?
That is the catch, right? Malware that can't run is well, it's useless.
It has to open on the target's computer.
And that is the brilliance of the exploit. It relies on the difference between being correct and being helpful.
Okay.
Tools like 7-Zip, they aim to be correct. If the file violates the rules, they reject it. They have standards.
What about Windows?
But Windows, specifically the File Explorer built into the OS, it just aims to be helpful.
It's the forgiving parent. Oh, you made a mess. Don't worry. Let me help you with that.
That is exactly it. Windows sees this 1,000 archive mess, and it essentially ignores the 999 broken parts. It doesn't care about structural purity. It just scans through the noise until it finds one valid file header, and it says, hey, I think I see something readable in here.
And it just shows it to the user.
It does.
That is wild. So the whole mess is specifically engineered to break the tools that follow the rules, knowing that the default Windows tool is loose enough with the rules to let it right through.
It weaponizes the apathy of the operating system.
Okay, I want to get deeper under the hood here.
Yeah.
You mentioned it's not just gluing files together. The report says they do something almost surgical to the file headers to force those errors.
Yes, this is where the real technical nuance comes in. It involves something called the EOCD record.
The EOCD. Okay, for those of us who don't dream in hex code, let's unpack that. What is it?
It stands for End of Central Directory. So going back to your book analogy, this is the master index at the very back of the book. It tells the software exactly where every file starts and stops inside the ZIP.
It's the period at the end of the sentence.
Exactly, and it signals this is the end of the archive. So what GootLoader does is it truncates it.
It cuts it off.
It cuts it off. Specifically, the malware cuts off the last 2 bytes of the EOCD record.
Just 2 bytes. In a file that could be, what, 100 megabytes large?
Just 2. But in file parsing, syntax is everything. Imagine reading a sentence that just stops before the period.
Right, it would drive a grammarian crazy.
And 7-Zip is a very strict grammarian. When it hits that missing data, it triggers a fatal parsing error. It assumes the file transfer was cut off or something, says unexpected end of archive, and just refuses to proceed.
But Windows?
Windows uses a different parsing logic. It works backward from the end of the file, looking for a signature. It finds what it needs and effectively ignores that the very tail end is missing. It just says, close enough.
It is amazing how fragile, strict software can be compared to dumb software.
Well, fragile is one way to put it. Secure is another. I mean, 7-Zip is technically correct to reject it.
But correct doesn't really help if the user can still double-click it.
Exactly.
The report also mentioned they randomize other fields, something about disk numbers, which sounded totally retro to me.
Oh, this is a total blast from the past. Do you remember multi-disk installs?
Like, please insert floppy disk 4 of 20 to continue installation.
That's the one. The ZIP format is decades old. It still supports spanning an archive across multiple physical disks. So GootLoader just inserts random numbers into the disk number field of the header.
So it tells the software, hey, by the way, I am disk number 42.
Right. And a strict tool looks at that and says, okay, if this is disk 42, where's disk 1? Where's disk 43?
It can't find them, so it errors out.
Thinks the archive is incomplete, but Windows, for single files, just ignores that field entirely. It just does not care.
So they're abusing features from the floppy disk era to hack systems in 2026.
History comes back to haunt us.
Now, all this randomization leads to another term in the expel report that sounded pretty intense. Hash busting.
Yes. This is a critical concept for modern defense.
Yeah.
If you understand hash busting, you understand why traditional antivirus struggles so much today.
Okay, break that down. What's a hash, and why do they need to bust it?
A hash is like a digital fingerprint. When security researchers find a piece of malware, they run a math formula on the file to generate a unique string of characters, the hash.
The fingerprint.
And then they tell every firewall and antivirus in the world, if you see a file with this fingerprint, kill it on sight.
It's the wanted poster. If you see this guy, call the sheriff.
Exactly. It's static detection. But GootLoader breaks this completely. Remember those 500 to 1,000 concatenated archives and those random disk numbers?
Ah, I see where this is going.
The malware generates a random number of archives, maybe 500 this time, 732 the next, and it inserts random values into those header fields for every single download.
So if I download the malware and you download it 1 second later,
We get the same malicious payload inside, but the container, the ZIP file itself, is structurally different. The fingerprint is completely unique.
so the wanted poster is useless because the criminal changes their face every time they walk out the door.
Precisely. That is hash busting. It makes static block lists totally futile. You can't just block the GootLoader file because there isn't one single file. There are infinite variations.
And how are they doing this? Is there a server somewhere just churning out millions of unique zip files? That seems expensive.
And that's the wildest part. It's not happening on the server.
Yeah,
It's
sure.
happening on your browser.
Wait, what? My browser's building the malware.
Yes, it's a technique called client-side construction. When you visit the compromised site, the server doesn't send you a zip file. It sends you a blob of encoded data.
What kind of blob?
Specifically, it uses XOR encoding, which is a simple way of scrambling data that's easy to reverse if you have the key.
Okay, so my browser gets a blob of nonsense. Then what?
Then, a script on the web page runs in your browser, decodes that blob, and starts assembling the file right there in your computer's memory.
Wow.
It takes that decoded chunk and just repeatedly appends it to itself, that's concatenation, until it hits a specific size, usually around 40 to 100 megabytes.
So the network security tools, the ones watching traffic coming in, they never actually see a ZIP file crossing the wire.
Correct. To the network firewall, it just looks like a stream of gibberish data. It's noise. By the time it becomes a recognizable malicious ZIP file, it's already sitting on your hard drive.
That is just deceptively clever. It bypasses network scanners because the file doesn't exist on the network. It only exists once it's fully assembled on the endpoint.
Yeah, it's like smuggling a gun through airport security by melting it down into metal buttons and then recasting it once you're on the plane.
That's a terrifying analogy, but it makes perfect sense. Okay, so we've got an impossible archive. It's unique every time, and it's built right under our noses. How does a user actually encounter this?
This is the social engineering layer. The core strategy is SEO poisoning.
Search engine optimization. Usually used to sell sneakers, but here, weaponized.
Right. The attackers compromise legitimate websites, often WordPress sites with poor security. They inject new pages into these sites that are designed to rank highly for very specific, very boring search terms.
Boring is key here, right? They're not targeting Taylor Swift tickets.
No, too much competition. They're targeting legal templates, contract agreements, employee health forms, things that people need for work often urgently and aren't suspicious of.
So I'm an HR manager. I need a 2026 contractor agreement template. I Google it, and the top result looks perfectly legitimate.
You click it, and you land on what looks like a forum or a document repository. And here they use another layer of obfuscation, custom WOF2 fonts.
WOFF2. Isn't that just a web font format? How is that malicious?
They use a thing called glyph substitution. You know how in a font the letter A looks like an A?
Sure.
Well, they create a custom font where the underlying code for the letter A might actually be mapped to display the entire word download.
Okay. That's confusing. Why do that?
To confuse the bots. To an automated web scanner that's just reading the raw HTML code, the text on the page looks like absolute gibberish, random letters.
But to me, the human.
To you, the human looking at the screen, the font renders those random letters as a coherent sentence. Click here to download agreement.
So the scanner sees XJ9 KL and thinks nothing to see here. I see download and I click.
Exactly. It creates a gap between what the machine sees and what the human sees. It's sneaky. So I click the button, the browser builds the file. I have the impossible ZIP, I double-click it, Windows opens it up. What do I see inside?
You see a folder. And inside that folder, there's usually a single file, and it looks like the document you wanted. It might be named Rental Agreement 2026.js.
And there's the sting, the .js extension.
Right, it's a JavaScript file. But because Windows hides file extensions by default, another one of those helpful features, many users just see the name Rental Agreement 2026.
And they assume it's a Word doc or a PDF, so they double-click it.
And boom! Now this is a crucial detail. Because the ZIP was malformed, Windows didn't fully extract the file it's letting you peek inside. When you double-click that script, Windows have to run it so it extracts just that one file to a temporary folder and executes it using wscript.exe.
wscript.exe, the Windows script host.
The native engine for running scripts on Windows. It's been there forever, since Windows 98. Once that runs, the malware is active. Code is executed.
What does it do then? Does it lock up your computer? No. GootLoader is just a loader. Its whole job is to get a foothold. It wants persistence.
So it wants to stay on your machine, even if you reboot. How does it do that?
It creates a shortcut, an LNK file, in your startup folder. But this shortcut triggers a second JavaScript file, this time using CScript.
C-Circuit. How is that different from RooScript?
They're siblings. Root script is for windowed scripts. C script is for command line scripts. Using C script lets it spawn PowerShell commands more stealthily to contact a remote server.
And it pulls down the next stage.
Exactly, which is often ransomware or tools like Cobalt Strike, which let human hackers move around a network. GootLoader is just the doorman unlocking the back entrance.
Jan, it's such a complex chain. SEO poisoning, font obfuscation, the impossible ZIP, temporary folder execution, PowerShell.
Yeah.
It's a Rube Goldberg machine of misery.
It is. But notice how almost every step relies on a legitimate Windows feature functioning exactly as it's intended to.
That's the really scary part. It's living off the land, using our own OS against us. So what does that mean for defense? If the security tools fail and Windows opens it anyway, are we just sitting ducks?
Not at all. In fact, understanding this whole mechanism points you directly to the defense. We have to stop the execution.
Okay, so if I'm an IT admin or just a tech-savvy listener, what's the move?
The first strategy targets those script hosts, wscript.exe and cscript.exe.
Can we just turn them off? Do we need them?
In most modern environments, no. Regular users, people in accounting, HR, sales, they have zero need to execute raw JavaScript files directly on their desktop.
So if we block them,
Organizations should configure security rules to block wscript.exe and cscript.exe from executing downloaded content, or just block them entirely for standard users. If you block that engine, the user can double-click that JS file all day. Nothing happens.
that seems like a no-brainer. But I know some legacy systems might still rely on those scripts. If you can't block them, the Expel report mentioned that really clever trick with Notepad.
Ah, yes. The notepad trick. This is my favorite takeaway because it's so elegant and it costs $0.
How does it work?
It's all about changing the file association. In Windows, every file type is associated with a program. .doc opens in Word. .html opens in Chrome. By default, JS is associated with the Windows script host.
Which runs the code.
Right. But you can use a group policy object, a GPO, to change that association for your entire company. You just tell Windows, from now on, JS files open with Notepad.
So instead of running the program, it just shows you the text.
Exactly. Imagine the scenario again. User falls for the trap, downloads the ZIP, double-clicks the file.
And instead of their computer quietly contacting a server to download ransomware.
Notepad pops up.
Yeah.
And they just see a wall of garbled code. var, x function, all that. They look at it and go, huh, this file's broken, and they close it.
Crisis averted. The malware never even ran.
It completely neutralizes the payload. And the beauty of it is you use the user's own confusion to save them. It turns that broken file narrative right back on the attacker.
I love that. It's actionable, it's low-tech, and it works.
It really connects to the bigger picture here. Defense isn't always about having the smartest, most expensive scanner. Sometimes it's about understanding the dumb defaults of your own OS.
So to wrap this up, we have GootLoader, which constructs these unique, malformed archives inside the browser to bypass detection.
It exploits the gap between strict security analysis and a forgiving user experience.
And it's a harsh reminder that compatibility and user-friendliness, things like hiding file extensions or opening corrupted zips, can actually be security vulnerabilities in disguise.
Absolutely. And it raises a really important philosophical question for the industry. We've spent years building tools that detect malicious code. We look for signatures of evil.
Right.
But GootLoader proves we need to get much better at handling ambiguous code.
Just because a file looks like garbage to a computer program doesn't mean it's safe.
That's the provocative thought I'd leave you with. In cybersecurity, we often interpret invalid as inert. If a scanner says, I can't read this, we assume, well, if I can't read it, it can't possibly run.
But it can.
GootLoader proves that invalid to a security tool might be perfectly readable to the operating system. And the attacker knows exactly where that line is drawn.
That is a scary thought, but a necessary one. Invalid does not mean safe.
Correct.
Well, on that cheerful note, I think I'm going to go check my file associations. And if you're listening, I highly suggest you do the same. If you double-click a JS file and it runs a script, maybe it's time to introduce it to Notepad.
Couldn't agree more. Simple changes, safe systems.
That's it for this deep dive into the impossible archives of GootLoader. Thanks for listening, and stay safe out there.
Curious?
See you next time.